Hello everyone, my name is Ankur and welcome to RJPT Simlab simulation. In this video, we will study about the anti-convulsant activity assessment using maximal electroshock method in rats. At the end of this video, we will be able to induce epilepsy, convulsions, seizures on rats, and then we will study the pharmacological effect or therapeutic effect of phenytoin against epilepsy because phenytoin is an anti-epileptic drug. So now let us start with the video. At first, let us see the introduction part. The introduction is about epilepsy, a complex neurological condition characterized by recurrent seizures affects millions worldwide. So epilepsy is a disease or is a neurological disease, is a neurological condition characterized by recurrent seizures and it affects millions of people around the worldwide. What is a seizure? A seizure is a sudden disruption in brain activity caused by abnormal, excessive electrical impulses leading to changes in the consciousness, movement, sensation, or behavior. So, seizure is a type of neurological disorder. To explore potential treatment, researchers turn to animal models that replicate seizure activity. Among these models, the maximal electroshock MES method stands out. By including convulsions in laboratory rats, MES mirrors the tonic-clonic phases observed in human epilepsy. So, the above line says that to explore these treatments about the epilepsy, the researchers found that the rat is a animal that mimics the human reactions of the epilepsy. So among these models, they have chosen the model of maximal electroshock method, MES also known as, and by this they induces the convulsions in the laboratory rats because the MES mirrors the tonic and clonic phases observed in the human epilepsy. Tonic-clonic seizures or tonic-clonic epilepsy. This refers to the epilepsy where generalized tonic-clonic seizures are the primary most or recognized seizure type. It is a type of seizures in which generalized electrical activity in the brain that causes a lot of consciousness and two main phases, basically tonic phase and clonic phase. The tonic phases refers to the stiffening of the body and clonic phases means that refers to the rhythmic jerking of the body. Okay, this is a type of seizure. And this epilepsy or seizure is associated with the conditions underlying such as head injury or stroke and can be result in the confusion or fatigue afterwards. In our study, we narrow our focus to phenytoin, a widely used anti-epileptic drug. Before embarking on this investigation, a solid grasp of anti-epileptic pharmacology is essential. Let's delve into the intricacies of this experiment. So before performing this experiment, we are using the drug phenytoin for this disease because phenytoin is an anti-epileptic drug. So now let us move forward. So the equipments required for this experiment are at first we have our apparatus electro-convulsiometer, then corneal electrode through which we apply 150 milliampere current for zero point 0.2 seconds and then stopwatch. Then the subject or animal we can say we have rat which is of 150 to 200 grams. Then the drug we are using phenytoin drug of which we will give 25 milligram per kilogram as dose. We have to prepare a stock solution containing 5 milligram per milliliter of drug and inject 0.5 ml per 100 grams body weight of the animal. Now let us see the principle. The maximal electroshock MES. This method stimulates grand mal epilepsy in animals. Grand mal epilepsy is also known as tonic-clonic epilepsy. It is another name of the tonic-clonic epilepsy. So MES convulsions phases. These are the 5 phases of the MES convulsions. The first is the tonic flexion. It is the initial phase with muscle stiffness. The muscle starts to stiffen. Then the second is the tonic extensor. This follows tonic flexion. After the tonic flexion, tonic extensor comes and characterized by the extension of the limbs. Then the limb starts to extend. Then the third is the clonic convulsions, repetitive muscle contractions. Then fourth is the stupor. Stupor is a period of altered consciousness And then fifth is the recovery or death, which means the outcome after the convulsions. Anticonvulsant activity assessment. A substance is considered anticonvulsant if it reduces or abolishes the tonic extensor phase of mass convulsions. Phenytoin is a known anti-epileptic drug. Now, this is the ideal observation table of this experiment. In this, we divide the animals into two groups. The first is the control group and second is the drug group. Here we have written phenytoin because we are using the drug as phenytoin. The body, we will measure the body weight, and then this will be the, here we have the five phases of the convulsions. First is the flexion, extensor, clonus, stupor, and the recovery or death. So we will measure the time according to these five phases for the control and the drug group, and then we will calculate the mean value of it. This is the comparison chart or flow chart, which is drawn according to the five phases of the convulsions: the tonic, flexion, tonic extensor, clonus, stupor. Okay. This is drawn against the phase and against the time conversion graph. So now let us see the procedure of this experiment. At first, we require the animal preparation and grouping. So we have to weigh and number the rats, then divide them into two groups, each consisting of 6 rats. For the control group, this group will not receive any drug treatment, and the test group, which is phenytoin group, this group will receive phenytoin as the anti-epileptic drug. Electroshock application and observation. Properly hold the rat and place corneal electrodes on the cornea. Corneal electrode. It is a device which is placed on the cornea of the eye of the rat to record electrical signals from the retina. So, okay. Now, after that, we will apply the prescribed current to induce maximal electroshock. Then we have to note the different stages of convulsions. The five convulsions that we know: tonic flexion, tonic extensor phase, clonic convulsions, stupor, and recovery or death phase. Then we have to record the time in seconds spent by the animal in each phase, then repeat the procedure with other animals in the control group after inducing the drug. Then third point is phenytoin administration. We have to inject phenytoin intraperitoneally to a group of 6 rats in the test group. We have to inject or introduce the phenytoin drug through the intraperitoneal route. The intraperitoneal route is the route in which we inject our drug into the abdominal region or abdominal cavity of the animal. So we'll inject our drugs with to the drug group, which contains 6 rats. Then we will wait for 30 minutes to allow the phenytoin to take effect. Then repeat electroconvulsions. Subject the animals in the test group to electroconvulsions as described in the step 2, as we have done for the control group, and observe any reduction in the duration of the tonic extensor phase of mass-induced convulsions. Then we have to observe that the tonic extensor phase is the second phase of the convulsions, of the phase of convulsions, that any reduction in the duration of time of the second phase is observed or not, and document any abolition of the tonic extensor phase due to phenytoin treatment. Then we have to record the data. Now, let us understand this experiment by performing it. And for that, we will perform this experiment on our RJPT Informatics Simulatory Laboratory. This is the UI interface of our simulatory laboratory. Here we can see that on the left side of the toolbar, we have the cage, the animal cage. Then we have the weighing scale, through which we will weigh the weight of the animals. On the right side of the toolbar, we can see a syringe pre-filled with the drug phenytoin. We can even also hide these sidebars by show and hide button, as we can see here. On the bottom side, we can see the instructions or procedure through which we will perform this experiment. On the left side of that instructions, we can see the timer, which will record the time of the phases of the convulsions. On the right side of that, we can see the next and skip button. On the top side, we can see the observation table drop-down menu. When we will click it, we will see the observation table of this experiment as we have seen earlier, which contains the body weight, the treatment, this is of the control group, then the 5 phases: flexion, extensor, clonus, stupor, and recovery or death. These are the 5 phases of the convulsions. By clicking this drug group button, we will see the table of the drug group. As we can see, the treatment, it has changed to the phenytoin, which means we have given the phenytoin drug. Again, we can move to the control group by clicking that same button. By clicking this procedural flow button, we can see the procedure flow chart of this experiment. These are the procedures that we will follow to perform this experiment. And these are the buttons by which we can click on any button and jump to that step immediately. We can move this by clicking it. And now we can again, by clicking this observation table button, we can move to the table. So now let us perform this experiment. As we can see on the table of the laboratory, we have our electroconvulsiometer. So we will start this experiment by following the procedures. First, we have to select the mice cage from the left sidebar. So we will click it. And as we can see here, we have the two cages, which is the first of the control group, second is of the drug group. And now select the weighing machine from the left sidebar. We will click it. And as you can see, the weighing machine is on the table. Now pick rat 1 from the control group for weighing. We have to take the mice from the control group. We will take it out, and with the help of a marker, we will make a line which denotes this is the first rat. We will weigh it, which is of 150 grams, and again we will place it inside the control group. Now we will take the second rat from the control group. We will mark two lines. As we can see here, this denotes it is the second number of the rat, and it has weight of 165 grams. Again, we will take the third rat, and like this, we will move on for all the six rats. As we can see here by clicking the observation table button, the weight of the rats are being observed in this observation table. As we can see here, the weight of the three rats are written over here. We can move it upwards also by clicking this. This is the fourth rat. By drawing four lines, we can observe that it weighs 180 grams. Again, we will place it inside the control group. After that, we will take our fifth rat. We'll mark it with five lines, which denotes fifth number, and we will weigh it, which is of 195 grams, and place it back. And we will weigh our last rat from the control group. We will draw six lines, which denotes the sixth number of rat, and then we will weigh. We will place it in the weighing machine. As we can see, the weight is 170 grams. And by this, from the observation table, we can see the weight of all the rats. Now we will properly hold the rat one and place the corneal electrodes on the cornea. So we will take the first rat, as we can see here. And now we will hold the rat one and place the corneal electrodes. We will place it on the cornea of the eye of this rat. As we can see on the top, we have our observation table, a small observation table for the current rat. This will show the serial number of the rat. This is the first, so it will draw first the four convulsions phases: tonic flexion, extensor, clonic convulsions, and stupor. This is the current step. This will show, and now we will apply the current. As we can see, the current has been applied to the 231 milliamperes, and the timer has been started, and it has shown that the tonic flexion has lasted for 4 seconds, we can call it. Now note the time of each stage with a stopwatch. Next, we will play next. This is the first track. The tonic flexion has for 4 seconds. Now note the time for each stop. This is the tonic extensor second phase, and the timer has started. As we can see here, the timer goes, and the tonic extensor has lasted for 19 seconds. And now we will move on to the next step, which is the clonic convulsion. We have written the 15 seconds over here. The timer has started. The clonic convulsion has stopped in the 25th second, and we will note it in the observation table, and we will move on to the next step and the last step, which is the stupor. The timer has started. The clonic convulsion lasted for 6 seconds. And the stupor, we will wait for the timer to see the reaction of the rat. As we can see here, this is our electroconvulsiometer connected with the two electrodes, the corneal electrodes. These are placed on the cornea of the rat. The timer is running. As we can see here, the timer moves, and as we can see now, The stupor has taken 127 seconds. We can also save the reading by clicking this button. And now we will move on to the next rat. Put the rat back inside the cage. And now we will move on to our next rat, which is the second rat. We will take the second rat from the control group and perform similarly. We will attach the corneal electrodes and then we will perform it similarly. We will apply the current. The timer has been started over here, as you can see. You have to apply the prescribed current. The tonic flexion lasted for 5 seconds. Then after that, as we can see that reaction of the rat, the tonic extensor lasted for 13 seconds, tonic clonic convergence for 6 seconds, and now we wait for the stupor. As we can see the reaction of the rat, it has lied down on the table. 231 milliampere current has been applied by the electro-convulsiometer to the rat with the help of corneal electrodes. As we can see, the timer is running. We have to note the time of each stage with the stopwatch when the time is over. As we can see here, the stupor lasted for 119 seconds. And now we will move on to our next rat. But before that, we will place it inside the control group. We will save the reading. We will remove the electrodes. And again, we will place it back inside the control group. Now we will take our third rat. We will take the mice. We will place corneal electrode on the third rat and apply the prescribed current to induce the maximal electroshock. So first we will connect the corneal electrodes and then we will apply the current, which is of 231 milliampere. As we can see, the timer has started. We can see the reaction of the mice. The second phase stretches the limbs. The first tonic flexions lasted for 6 seconds. As we can see, the limbs moves upward and backward and forward. The tonic extensor lasted for 14 seconds, tonic convulsions for 5 seconds, and now we wait for the stupor's reaction. Usually it takes 2 minutes or 120 seconds or 125, near around that much. So we have to wait for that till that. And these are the control group rats on which we have not applied any or we have not administered any drug. As we can see, the timer moves, timer runs. 2 minutes have been passed, but the stupor hasn't arrived. The stupor phase of the convulsions of the control group. As we can see, the stupor has lasted for 124 seconds. Now we will save the reading and put the rat back inside the cage. We will take out the corneal electrodes and now we will put back the rat inside the cage. As you can see, the rat has recovered. And now we will put the fourth mice. We will take the mice from the control group cage. First, we will connect the corneal electrodes similarly. And now we will apply the current. By clicking the skip button, we can skip to the next step. So when we will click this, as we can see, the tonic flexion has arrived at 4 seconds. Again skip. Then the tonic extensor will arrive at 12 seconds. Then again skip. Clonic convergence has arrived on 4 seconds. And now by clicking the skip button, as we can see, the stupor has arrived in 115 seconds. Now again we will remove it. The rat has been recovered and again we will place it inside the control group. Now we will take the fifth rat from the control group. We will take out. We can also skip this. As we can see, we have connected the corneal electrodes to the rat. And now we will note the each time tonic flexion in 3 seconds. We will wait for tonic extensor. Tonic extensor lasted for 9 seconds. Tonic convulsions for 3 seconds. And the stupor We will wait for the stupor. When we will click the skip button, we can see the stupor lasted for 110 seconds. Now we will remove the corneal electrodes and put the and wait for the rat to recover, and then again we will put inside the control group. Now we will take our last rat, the sixth rat, and apply the electric current to induce the epilepsy. Now at first we will connect the corneal electrodes to the cornea of the rat, both the terminals to the connected to the electro-convulsiometer, and after that we will apply the current. Now we will wait for the tonic flexion, tonic extensor, tonic convulsion, and stupor. As we can see, tonic flexion lasted for 4 seconds. We will wait for tonic extensor. According to the timer, we can see here tonic extensor for 13 seconds. And now it's the third phase. As we can see, it lasted for 4 seconds. And now we'll wait for the stupor. We will wait for the stupor phase to get over. The timer runs according to the phase. The current has been applied of 231 milliampere from the electroconvulsometer to the rat, which they are connected with the corneal electrode. As we can see here, timer is running and a stupor has arrived at the 117 seconds. We will save this reading and move forward. First, we will remove the corneal electrodes and wait for the rat to recover. As we can see here, the rat will stand again. We will wait. As we can see, the rat is recovered and we will put them inside the control group again. Now we will click on the syringe. So these are the 6 pre-filled syringes with the phenytoin drug. We have to pick the rat one from the drug group cage and weigh them and apply the phenytoin drug. We will click the next button, and after that we will take the first rat and we will mark a single line and we will weigh it. It's of 155 grams and we will place inside the drug, inside the cage. Again, we will take it out and we will, through the intraperitoneal route, we will inject the phenytoin drug and we will place it inside the drug group again. Now we will take the second mice. Similarly, we will mark it with the 2 lines which indicates the second rat. We will weigh it. It's of 165 grams as we can see here on the weighing machine. And now again, we will take it out and inject the phenytoin drug through the intraperitoneal route as we can see in the close-up portion. Again, we will place it inside the drug group. Similarly, for the third rat, when we will click the skip button, we will move for the fourth rat, fifth rat, and the sixth rat. We will pick our last rat. We will make 6 lines. As we can see here, 6 line indicates the sixth rat. And now, after drawing 6 lines, we will weigh it. It's of 170 grams. And we will, again, we'll place it inside the drug group. And we will take it out for the drug administration through the intraperitoneal route of phenytoin drug. And then after that, we will throw the syringe. We will use each syringe, different syringes for different rats. Now we will wait for 30 minutes to let the drug take its effect. After 30 minutes, the drug will show its pharmacological effect or therapeutic effect. And then we will connect it with the electroconvulsiometer and check the effect of the drug against the epilepsy. We will skip this part. Now we will place the corneal electrode for the rat one and apply the prescribed current to induce MES. We will take our first rat. As we can see, similarly, our observation table of this drug group is placed on the top, and now we will apply the current. The current step will be shown over here, which is the tonic flexion. The 231 milliampere current has been applied. Now we will click the next button to move to the tonic extensor. The tonic flexion lasted for 3 seconds. We'll click again next. The tonic extensor lasted for 3 seconds. The tonic convulsion lasted for 2 seconds, and now we wait for the stupor. Through the electroconvulsometer, the 231 milliampere current is been supplied to the rat. which is connected through the corneal electrodes, which are connected from the cornea of the rat's eye. As we can see, the timer runs. We have to note time of each stage with the stopwatch. As we can see, the stupor lasted for 60 seconds. As we can see, it is lesser than the normal rat. After administering the drug, we will save this reading, and now we will move on. We will remove the corneal electrodes and move on to the and wait for the rat to recover. After some time, we will observe that the rat will be recovered. It will stand on its own. After again, we will wait. And now, as we can see, the rat has stood up again, and we will place it inside the drug group cage. Now we will take the second mice similarly, connect it with the electro-convulsiometer, and we will apply the current. We will apply the current and wait for the all the four phases of the convulsion. The tonic flexion has shown in 3 seconds, the tonic extensor in 4 seconds, clonic convulsions in 3 seconds, and again we wait for the stupor, which lasted 60 seconds for the first rat. Now we will see how much it lasts for the second rat. As we can see, the timer is running, and according to the timer, we will record the stupor. As we can see, stupor lasted for 58 seconds. Now we'll save the reading and move on for the next rat. But before that, we will remove the electrodes from this rat and wait for the rat to recover. Slowly, we will remove these corneal electrodes. Otherwise, it can get hurt. The rat can get hurt. And, and now we wait for the rat to recover. As we can see, the rat stood up, which means it has been recovered. And now again, we will place it inside the drug group. Similarly, we will perform it for the third rat. We have to place the corneal electrodes on the third rat and apply the prescribed current to induce the mess. We will connect the corneal electrodes and we will apply the current. As we can see on the observation table, the tonic flexion lasted for 2 seconds, the tonic extensor for 3 seconds, clonic convulsions for 2 seconds, and now we wait for the stupor. The stupor usually takes 60 seconds, is taking usually 60 seconds in this drug group. The first one took 60 seconds, the second one took 58 seconds. Now we will wait and see for this third rat. By clicking this observation table, as we have seen, this is of the control group. By clicking the drug group, we can see that we will see this reading. We will see that the second rat has shown this 3, 4, 3, and 58 seconds of these tonic convulsions of these convulsions phases, and it has been recovered. Now we have put the third rat again over here. Now we will take the fourth rat. The third rat observations are recorded over here. We will move it upward. And now for the fourth rat, we will apply the current. We will skip. We can skip also by clicking the skip button. As we can see, the fourth rat has shown that the tonic flexion was for 3, tonic extensor for 2, clonic convulsions at 2 seconds, and stupor lasted for 48 seconds. This is a very much reduced value after administering the phenytoin drug from the control group rats. After the recovery of the rat, we will wait for its recovery. As we can see, the rat has been recovered. Now again, we will place it inside the drug group. Now, after that, we will take out our fifth rat. As we can see, we have taken out and connected the corneal electrodes, and now we have applied the electricity. As we can see on the table, tonic flexion is for 2, tonic extensor for 3, clonic convulsions for 3, and now we wait for the stupor. When we click the skip button, we can see that the stupor lasted for 45 seconds. Now again, we remove the corneal electrodes of this fifth rat, and now we wait for its recovery. And after that, we will move on to our last rat. We will connect the corneal electrodes and we apply the current. By clicking this apply current button, we will apply the current from the electro-convulsiometer. We provide a 231 milliampere current through the corneal electrodes to the rat. As we can see, the tonic flexion has shown for 3 seconds, tonic extensor for 4, convergence, clonic convergence for 2 seconds. Now we wait for the stupor. As we can see, we can observe the reactions of the rat. You have to note the each time for each stage with the stopwatch. As you can see, the timer runs. And now we will wait for the stupor. The stupor lasted for 56 seconds. Now we will save this recording. And now we will remove the corneal electrodes of the rat slowly. As we can see, we have removed the corneal electrodes. Now we wait for the rat to recover. As we can see, it has lifted its tail and now it will stand, which shows the indication that the rat has been recovered from the convulsions. As we can see, the rat stood. Now we will place it again inside the drug group cage. Now we have placed the rat again back inside the cage. Now we can see that we have performed for the both control group and the drug group. By comparing both the groups observation table, we can understand that after administering the drug, the phenytoin, we have seen reduced effects in the phases of convulsions and the recovery has been followed. Now we will exit our laboratory and we can see the discussion part. The result says the control group, rats subjected to maximal electroshock mess without any drug intervention observed mess-induced convulsions including tonic flexion, tonic extensor, clonic convulsions, stupor and recovery or death. Drug treatment group. Phenytoin. We have introduced phenytoin. It is an anti-epileptic drug. Administered phenytoin intraperitoneally to rats. Noted the effect on mass-induced convulsions. Observation: reduced tonic extensor phase. Phenytoin significantly reduced the duration of the tonic extensor phase. As we can see here, the tonic extensor phase has been reduced. Not only tonic extensor, the flexion, clonic, and stupor. All these phases have been reduced or decreased the duration of time. So, which shows that this phenytoin has significantly shows its therapeutic effect and it works against the epilepsy. Anticonvulsant activity. Phenytoin demonstrated anticonvulsant properties by suppressing the most severe phase of the convulsion. These are the most severe phases, and the most of them is the extensor phase, tonic extensor. And phenytoin has reduced the tonic extensor phase duration. Comparison. Compared results between the control and the drug treatment groups. We have observed that the phenytoin has shown a good therapeutic activity against epilepsy. Phenytoin's efficacy is in reducing mass-induced convulsions validated its anti-epileptic potential. Conclusion. Phenytoin holds promise as an effective anti-epileptic agent. Further studied are warranted to explore its mechanism of action and safety profile. The conclusion says phenytoin holds promises against anti-epileptic agent and further studies are warranted to explore mechanism of action and safety profile of the phenytoin drug. So now we have completed our experiment. And I hope that you have learned that the phenytoin is an anti-epileptic drug and it shows its therapeutic effects against the epilepsy. By performing this experiment, we can say that the control group on which we have induced epilepsy with the electroconvulsiometer has shown the 5 phases of the convulsions, and after administering the phenytoin drug, the duration of the 5 phases of convulsions has been reduced. So this shows that the phenytoin is an effective anti-epileptic agent. So now we have come to the end of this video. Thank you guys for watching this video. I hope that you have learned a lot in this video. And for more such learning content, subscribe to our YouTube channel, RJPT Informatics. And you can also follow us on our LinkedIn profile, on Instagram, as well as in Facebook. We update and upload our such learning content over these platforms. Thank you.